Okay. Quick little bit of background with this, because I think it's necessary. This is a talk I've wanted to give for a while, and it's a talk I was very excited about writing. Not just giving the talk, but the actual process of writing it to begin with, and everything like that. And what's coming to mind at the minute is there's a wonderful film. I don't know if any of you have ever seen it, called 1 Hour Photo. It's one of Robin Williams' best films. And there's a little quote in that about the fact that if we only judged our lives through the photos we take, then we only ever take happy photos, and everything is only happy. I know this is a strange way to give a talk, but I submitted the abstract for this, and I wanted to write the talk, and life had slightly different plans, and my mental health took a really bad downturn, which means that I only returned to work just over a week ago, which means that my colleagues, Matt and Joe, have written the bulk of this talk for me. And for that, I am immensely grateful. For my line manager, Pfizer, for his support through all of this, I am even more grateful. What this will mean, though, that when combined with my neurodiversity, I may forget what I'm meant to be doing on certain slides, and it may be a little bit jumbled, but I will try and keep it consistent. So a little bit of background on CEH, or the UK Centre for Ecology and Hydrology. So our role is to work with the virus, is to advance environmental science that businesses, the non-government organisations and researchers rely on to meet the challenges of our time. We're based across 4 sites primarily, headquartered in Wallingford. We have sites in Bangor, Lancaster and Edinburgh. Lancaster is where myself and the majority of the digital research team are based. Matt is our only RSE down in Wallingford, and then we have a further 2 RSEs based up in Edinburgh. We do have an international site in Ghana as well, which is a new venture. So as I said, we're environmental science. We work on the environmental science that is needed to benefit the UK research community, but also for governments and businesses and society in general. And this means that we work on a wide variety of projects, and many differing projects. Even though it's one core theme of environmental science, what we work on can be quite widely different. So we have large-scale monitoring networks and observation networks to measure environmental change. But we also work with citizens. We have lots of public engagement, sort of citizen science activities. I've only been with UKCEH for a little over a year now, so I'm sort of getting to grips with what we have. But the ones that I've seen going across my desk are things about insect populations and bees and bats and various levels of citizen science and monitoring. And this requires applications to be developed and infrastructure to be built. And then we have the larger scale research infrastructure and the monitoring that we do across the many sites we have across the UK, the massive modelling that's built on this and the data science that comes from all of this. And this requires projects that run for a long amount of time, hardware that has to stay working, whether we can get to it easily or not, whether that's being because it's floating in the middle of Windermere or it's in a field somewhere that's harder to get to than harder to get to than most places in the UK we're trying to use public transport. And we're also leading the efforts to tackle global challenges by working with the United Nations agencies and their programs and leading the way in environmental research. Several of my colleagues have just come back from various conferences where they're trying to get international agreements together based on our research to try and help the environment, such as, limiting the use of microplastics because of how much they're turning up in the water and the food supply at various levels of that. So who are we in terms of skills? Well, this is a nice time diagram of sort of what people in the organisation associate with their jobs. We are varied. We have everything from scientists to data analysts to field technicians, information managers, research softwares. Much like a university, but we're all, it feels like it should be easier because it's just one subject area. And also, on top of this, we work with a variety of tools and programming languages. It's not even that we can just be simple as, oh, we just do environmental science in R. We have every programming language out there that we're using for various bits, and some of the older ones. So it requires this varying skills across not just the RSEs, but the majority, all the other research technical professionals in the organisation. Right, this I might be Matt's help because I'm very good with certain technology, but there's a pause to give me a chance for some water as well.
Very helpful. You said that we can definitely apply that to the conference one. But I believe it is a simple, let's go to the website, I believe a different code. Which the question is, we want to know how many of the things that we just showed you do you recognize or even have experience in? I think was what I was going to ask. There we go. Let's go back up. Yeah, results. That's already inverted. Yeah. Something that I don't even recognize. I'm not sure where to go. Still, that's giving people plenty of time. And I guess that's about what we expected, I think. Yeah. No one, no one's in the at the end, I guess, make sense. But even though some of you recognize that.
So the fact that you recognise them, you can see the breadth of tools that we have to deal with and find ways to support and get them to connect. And in many cases, as always with research software, it's not just a case that a particular piece of analysis begins in Python and ends in Python. It starts in one of those, goes through half a dozen of them, and then we finally get something at the end that we probably want to put into something like Excel to send to a government department. So the way CEH, UK CEH is organised is we're into science areas. These are broad areas that cover the various parts of environmental science that we're doing. And the area that myself and Matt sit in is called National Capability in Digital Research. And this is kind of basically two areas smudged together. We have the National Capability Delivery, which is that big national capability grants and projects that we do on behalf of government. They have one group to organise them, and then we have the digital research group. And this is the core bit that sort of relates to this conference. This is where we're driving and delivering that digital research infrastructure at UKCEH. You know, we're enhancing the integration and impact of these digital assets that we have. And by digital assets, we mean data, methods, models, tools, almost anything digital you can think of. And then we're developing novel and automated DRI technologies through this sort of agile customer-first approach. I'm going to go back to the word novel. I struggled with this coming from a physics background, where novel research means something very specific. Here, we mean things that probably aren't novel to computer science, but are to environmental science, because we've never put the two together before. And we also spend a lot of time researching and exploring the emerging technologies to see what we can then use to support the DRI program that we have. So we have our data scientists and our RSEs looking at how we can use AI and large language models as part of our research. And also we're looking at the sustainability in terms of the green computing side of sustainability when it comes to all of the digital research that we're doing, because, well, first of all, it's important, and secondly, it's really bad as a centre for ecology and hydrology not to focus on the sustainability. So we're a large group, we're about 45 people across the group, 46 people maybe, and this has varying roles and job titles. But it's a large interdisciplinary team. We're based pretty much in one office, which means communication between us is very good, and we also do it remotely over Teams. and it allows us to support all those researchers. But on top of that, researchers often don't know what skill sets they need. So they'll come in to, they'll come to the team and ask about something, such as how do they store the data at the end of their project? They're more likely to ask that, I think, than ask for research software engineers some days. But because we're one team, we can, we can look at something, oh, well, you can store the data like this, but to store it like that, you're probably going to need the help of some of the research software engineers. And you seem to be doing something nice here, so maybe you want the data scientists to help. And we can give the researchers the full breadth of skills of our group. And this is important because at the end of the day, we want to try and minimize wasted effort by researchers. If we can make the data sets more discoverable, someone else doesn't have to create that data to begin with or spend ages finding it. If we can make those data sets more accessible, time isn't wasted trying to just get the data in the first place. We can adopt the new technologies and spread them out across many researchers, and we can find more ways to collaborate across disciplines. And that's across the very specific disciplines inside environmental science. So the way we're organised is primarily into 3 teams inside one group. So we have the data and digital integration team, and they focus more on ensuring that what researchers do meets with the FAIR criteria, and that they're turning those digital outputs that they have, the digital objects, the data sets, and various other assets, and making them impactful, making it so other people can use them, find out about them. Then we have the digital engineering team. This is primarily composed of our software engineers, not our research software engineers, but our actual software engineers. And they're doing the big scale infrastructure projects, the data science. What's the word? I just lost it. A bit like Loom. The sort of data science environment that we have for doing research within, the big data catalog that holds all the metadata and allows searching of those data sets. And then we have the digital innovation team, which I think is the stranger one of the 3, because it's even more varied in the skills. This is our data scientists, our human-computer interaction specialists, our sociologists, our colleagues with sociology backgrounds that can do heavily on the co-design and community engagement, our designers, and I mean designers not in the UX sense, designers from a traditional design background, helping with the dissemination of research to the public, and our research software engineers, which is myself, Matt, and 3 of the colleagues. So I forgot we had this slide. I like this one. So before I actually talk a bit more about DRI and what it means to us, what does DRI mean to you? Not only, let's have some interesting names to add some humour into the middle of it, but actually, what do you think of when you think of DRI when it comes to research? So we'll lose that for a couple of minutes. Second. I agree, it's what you call a good acronym. Yeah, there's a correct answer is don't really understand. What do I think about this? Real innovation. I do like that. Yeah. Okay, which one of you is in there that says Jasmine? Yeah. Being a sensible answer. That's a little bit of fun. But the trouble is, we all have different definitions of digital research infrastructure. Back in my long forgotten, trying to express particle physics days, digital research infrastructure was the HPC. That's it. That's all we cared about. But for UKCEH, it means a lot more than that. Digital research infrastructure brings together the data sets, the models, the data science methods, the analysis, the visualization tools, the platform. Essentially, if it is digital and it is used for research, it's digital research infrastructure. I guess we also include the human element in that, although I don't want to dehumanize them too much. It is the skill sets that we have, it is the RSEs, the data scientists. They're critical in maintaining and producing this digital research infrastructure. They're part of it and need supporting. So we have our monitoring infrastructure. So that's the sensors, the IoT devices, citizen science. And actually, thanks to one of our colleagues, Joe, and an SSI fellowship, there's more research now going into the open hardware side of things as well, so that we can sort of take that open source level to the next stage, to another section of the DRI pipeline with us. It is the traditional computational infrastructure as well, so Jasmine, Polar, the Environmental Information Data Center, the EIDC, and also the personal devices, the laptops, the smaller machines that we're actually doing that research on. We've got to maintain those, the platforms that we have as well, such as our data science infrastructure, where we have to have those within digital tools that we can support and make reproducible as well. And then it's those digital tools as well, the software that we have, the data stewardship wizard, which is a wonderful tool that helps our researchers figure out what they've got to do with their data and their requirements for things. The catalog, which holds all of our data sets and allows you to search through it. And then things like our Shiny and our portal and applications like that. So it's everything. And supporting it takes quite a lot of effort and a lot of skills. So I guess the next sensible question is, how do we do DRI? And for that, it's our core principles. Because DRI is everything and it's a part of everything we do, we need to find a coherent way to do it. Because if we try and support every bit of DRI that every researcher has, we won't have enough research technical professionals to do that. We have to find a way to bring it down to something slightly smaller. And we do that with our core principles. So we embed co-design and engagement in everything. We can build the world's best tools, but if no one's going to use them, it wasn't a great use of our time. We drive continuous innovation in all of our projects. So that's not just bringing in new technologies, but that means if a researcher wants to do something new, actually this goes into the second one, fostering inclusive and interdisciplinary collaboration as well. If researchers want to do something new, can we enhance a piece of existing infrastructure, one of our current systems like our data science platform, data labs, or our catalog? Can what they want to do be added to that? Because it's a lot easier to maintain one ever-growing piece of infrastructure than it is to maintain lots of little individual services. So when we take on projects, we try and make sure they fit with our DRI strategy and that they fall into this sort of aiming towards one DRI way of doing things. Okay, so when we're looking at these, I'll apologise, I've got interesting titles for the next few slides. So from the cradle to the grave, the best way for us to get involved with the project is at the moment of inception and take them all the way through to production. Now, by production, I mean production level, but not every piece of software, every tool, every project we're going to do wants to be production level. Some of them are going to be hopefully not single-use software, but they will be smaller use. They'll be used by small teams. They won't be used as often. They might not be used outside of UKCEH. But those projects at some point might have the potential to become production level software that's going to be used by the wider environmental science community. So we need to make sure that any projects that we're involved in can go from one stage to the next easily without having to start over again. We're still learning on this. There's a lot to learn. I took a lot of notes from King's Digital Lab the other day on how they do some things. Um, but this means the processes that we're using have to be flexible. Our digital engineering team tends to work in the sort of Scrum methodology for Agile. It also works in Agile, which isn't always something our researchers want to work with. The digital innovation team leans more towards Kanban. So we've got to find ways to work across our three groups as we pass projects between them. So we need to ensure all these areas and people that came in from varying backgrounds work together. And I would love to tell you we've solved that one. We're working on it. Oh, I touched on this already. Theory meets practice. So, Agile is great for our digital engineering team until we meet with the scientists. Telling them to do their research in 2-week chunks and get back to you is not always popular with them. It's not the way they're working. They're working on way more projects than we are often as well. So we have to pivot on some of our projects to Kanban. We also found, and I think Matt will talk on it later, that in some of them where the projects are still developing, I put Agile, I mean Scrum really. Scrum doesn't work when the hardware is evolving. We're still trying to write the software for it. So we've still got many projects that run like that, but we've also got projects where it's a single RSE or a single data scientist working on the project, and Kanban works a lot better in that system for us, and then bringing other people into those things. This again, playing nice with us. So it's this working with the researchers. One of the ones that we brought in recently, and we're trying to use more, is a lot of the large projects need larger project management, and they've kind of done something that looks a little bit like Prince 2, especially if you squint at it. And that's, it's a civil service way of managing things with lots of layers to it, but it allows the PIs to interact with these large projects and allows us to know what we've got to create at each stage. What we found with that is then onboarding people becomes a problem because the PI and project managers won't understand the technical infrastructure. So we've started having technical leads coming in to fill in those gaps to actually properly onboard people into these big projects, what the infrastructure is we're using, what the methodology we're using is, like Kanban, and help them with that. And this is meaning that we're upskilling all the researchers as they're coming in to talk the same language that we are, which helps. And as I mentioned before, the earlier we can get in, the better. The earlier we can engage with the researchers, if we can get them when the project is still just an idea in their mind, instead of when it's been funded and they come to us with a few hours and ask us, well, you are wearing the right t-shirt for it today, when they ask us to be unicorns and do magic in a few hours of work, that's very hard. So the earlier we can engage with them, the more we can shape the project, we can bring in other parts of the team then, because it's very frustrating to be working on a project as a research software engineer going, my life would have been easier if the research data manager had been involved and covered that part of it and got this sorted for me. And it would have been a lot easier if the data science team come in and helped us curate the data to begin with and design the methods that are then going to be used. So being part of this big diverse teams means that when we engage early, we can nudge the researchers and go, hey, have you seen the research data managers that we've got here? They can help you with this. They can make your life easier. Have you seen the data scientists? They can do this. We bring in all those skills under one roof. I wasn't going to write out fair again. Of the people, by the people, for the people. As I touched on earlier, it's pointless designing nice digital research infrastructure, be it the large-scale pipelines or just tools, if no one's going to be using them and no one's going to engage with them. So we want to use co-design and stakeholder engagement. This is the key to doing any of the DRI that we do. And the more that we can use that, the more we can understand the problem that we've got to begin with, curate what we're doing to match exactly the needs of the users and ensure that more people are going to use it, and then more environmental science can be done and better environmental science can be done. Okay. So I'm going to hand over to Matt for a little bit. We've basically got 2 case studies now looking at 2 of the larger projects we've done what we learned from them, how we put some of these skills into practice, and just a little bit of information.
One of which would be the first one, which I know a little bit about, a fair amount about, and the second one of which I know very little about. So this could be interesting. FDRI, it's a big project that we're working on. And this is another fun, this is where the idea of the Slido thing came from, is that it's very helpfully, the acronym contains DRI, does not stand for Digital Research Infrastructure, but the project is largely about research infrastructure, which just adds to all the wonderful confusion around the stuff. It's floods and droughts research infrastructure, so arguably two of the words were almost right. Part of which is, and I'll get on to, it has to be digital. The idea behind the project is it's an infrastructure project, so it's not a research project, which is more unusual for our organization, but it's made a nice change. Essentially, it's a capital investment from the relevant research council, which name I forgot, to build and upgrade physical and digital infrastructure to help the hydrological research that goes into predicting floods, drought, monitoring rivers, river catchments, and all that sort of stuff. Or as the blurb, so the tagline of the project says, scalable systems that collect and analyze the diverse and near real-time data for monitoring sites. I probably didn't need to read that out. I'm sure you can all read. I prefer to try and at least explain it in slightly more applicable English. The reason I chose this example because again it speaks to the fact that it's a huge diverse project, lots of different moving parts, lots of different people and skills, and trying to make this all work together has been an interesting challenge. So we have so on the people side of things, there's the actual engineers building some of the physical infrastructure and the equipment, field engineers who are going out to try and install this. Then there's the technical teams behind them, trying to get the software they've written to work on these new monitoring stations. And then the sort of the underlying digital infrastructure that is there to manage some of this data. And it's not just field sites, it's also the modeling that needs to be done on that data as well. So that involves the digital side of things will involve some computation, unsurprisingly, and the platforms on which we do that is being well, at the moment we're working largely on AWS. I'm not quite sure where that came from. I wasn't involved in that particularly, but they're trying to build something that is as migratable as possible between either our on-premises infrastructure, which is in development still, I would say, or other cloud systems as appropriate. That's sort of the big part of the project is to do that. And some of that will involve working in different ways that we're used to, and that's this is where the sort of the agile methodology of the digital engineering team, I should say, the software engineers, rather than against some of the other ways of working that have been historically in the organization. And I should say I chose the picture on the left just as an aside because that Alba was one of our became an RSC after doing a lot of work in the field on this sort of stuff. So I thought that was a nice note there. I only think that slide is horrible. This is very much pulled from the official slide deck for this project. Just again to illustrate the diversity, there's a huge variety of different data types that need to be taken account of. Some of which are on here, and some of which I didn't actually know about until I tried to make this slide. So I didn't know what a phenocam was, but apparently it's a webcam that goes on a field site that you can just see the general conditions around it. Yeah, I mean, again, I could read through these, but I think it's more illustrative than anything else. Probably don't need to do that. The more interesting bit, I think, really, and you've got a feel for the project, is how we actually try to make it all work. So I just sort of mentioned earlier that I said with Robin, that the digital engineering team, the software developers that we have, made a decision to go quite what's the word I'm looking for? Can't remember, but really took up. I'm not sure that's a word. Scrum and Agile, I'm working in that development methodology, which was new for some of them, definitely new for a lot of people in the organisation, and therefore because of this decision, there was we had a specific role that was hired, which I believe the terminology is Scrum Master, which I still find that some of the names of things a bit weird, but so it was new to me as well for a large part of it. It was needed to try and introduce this new way of working for some people, and essentially herd the cats that is a combination of scientists, software engineers, research software engineers, and field engineers and the like. As you would imagine, this is not going to work perfectly. Introducing a new system to a new way of working into an organisation that, whilst not academia, is still has some of the working practices that the ways of working inherited from it. So one of the main problems that the developers had, which I found quite interesting, and I'm sort of speaking from second-hand knowledge here, not first-hand, is well, it comes from the fact that people were working in an organisation with people who haven't done this before, and they were getting lots of requests and demands on time, and this idea of blocking everything into, no, I'm doing this 2 weeks sprint at the moment, this is what I'm focusing on, and everything else has to wait. Yeah, that didn't go down too well a lot of the time, and people being caught in the middle of that sort of friction wasn't too great. But I found that interesting because I thought agile and flexible were sort of synonyms of each other, and it was supposed to be relatively flexible, but that's what you get by trying to put these things into practice. Nothing's usually as quite straightforward as the theory suggests. I guess I sort of touched on the other bullet point as well, that people sort of outside the digital development work that was going on struggled to know where the best place to engage with. Where do I give feedback on this? How do I know how you're getting on? What is this Kanban board website thing you sent me to? That kind of stuff. But it's a learning process. That's the main thing. No one's solved all this, I think. But so after having trialed that for, I think it got close to a year in the end. We did do a a retrospective, I think is the term for it, looking back over the year and trying to actually work out what were the issues, which has enabled me to actually put them on the previous slide and work out what they actually were and whether we can actually make this a bit better. So as a result of that, the software development, I keep calling them the wrong name, the digital engineering team, strictly speaking, but software engineers, it works just as well in my mind, have not have stepped back a little bit on the way they work. So yeah, basically they're taking out Kanban, and that seems a little bit, I don't know much about this because I'm not on the outside of it, and was sort of writing this the other day and trying to work out what was going on, but that seemed to be the feedback we were getting was that allowed a lot more flexibility in the way that they were working, and it was something that researchers and the other people working on the project could get more involved in a little bit more easily, particularly when a lot of them, what's the word, the language around Scrum and all the ceremonies and the vocabulary that I think was quite off-putting was sort of dropped in favour of more understandable terms that allow people to know where to engage more. So language matters, I guess, was what we learned from that, and trying to get and building on the sort of the mandated by Scrum show and tells, or the this is what we've done end of a sprint kind of wrap-ups, and adapting those into sort of we have now a varying format for those that depends on the different level of interest that different people in the project have, and then so those in them, so just as an RSC on this project, it very much felt like so I sort of knew what the software development team were doing, and I sort of knew what everyone else was sort of wanting from them, and trying and how this process of communication wasn't going. So one thing that I've done and a couple of others of RSCs on the project trying to do is adopt a sort of, and it sounds too formal, but it's good enough agile. Well, I see it as good enough Kanban. I have a Kanban board, And I basically said, this is what I'm doing, and this is how it, where you have a nice 3 columns, easy to understand by people, but you don't need to get bogged down in all the nomenclature and the doing things rigorously. And it also doesn't work when there's only 1 or 2 of you in the area. They get on. What else do I want to say? Community conversations, where did that come from? I think that was more at a stage that again sort of came out of the Shuttle Tales, but it talks about this. I can't say it with a straight face. I'm very much trying to do it. The co-design and stakeholder engagement stuff that we were talking about earlier, which though I can't say it with a straight face, is an important thing when it's done well and it's done right, but it just becomes a bit of a buzzword for things. So this perhaps was not something that came out of this yearly retrospective that we were having, but just something that was a natural part of the project that we wanted to bring in at this time, and this part of the project being sort of second year of a 5-year project now. This is the idea of, now that we've got a working prototype for some of the things that we're trying to build, now is the time that we can put those in front of people who we think are potentially wanting to use them. We did obviously have use cases right back at the start, but now that we've got something physical and they can see it, that's the great, that is, I can see it happen. It's a great way of getting very quick, easy feedback and knowing exactly how people are going to be using this stuff that we're building and making adjustments based on that. I think that's enough talking about that.
I think it's conclusions.
I think I may skip the next one, given I don't actually know much about it. I thought of one I thought into that, so apologies.
So I'll skip to the last slide, which is, where we're aiming to go with things in the digital research group. So, our reorganisation into the digital research group is quite new. We're trying to take what we've learned in these projects that we've been doing so far and push them through. So it's this embedding co-design engagement, sort of community conversations, this driving the continuous innovation of these sort of one DRI projects where we can try and group things together. And then promoting this inclusive and disciplinary collaborator. Why are there so many long words here? And then embedding the FAIR principles and everything we know that's good about research software engineering and data management and software engineering and data science and data discoverability, and bringing them all together so it just becomes common practice inside UK CEH and allows us to develop the best digital research infrastructure we can for environmental scientists.
Okay, great. So the top question is, you talked a lot about how your teams work and there's multiple RTPs and things like that. How does this actually work in practice? I guess you talk about Scrum and Prince too. How do you actually assess the amount of each RTP type you need? How do you schedule that, then plan it, expand the teams to meet project requirements, do that all that forward look sorts of stuff as well?
I guess the technical answer is organically. We're still figuring that one out. We're still used to projects coming in with requests for one particular RTP. And we're just trying to navigate our way through that at the minute. Part of that comes because when a request comes in, we actually hand it out to the individual teams. We don't have the managers looking at it at a top level and going, well, it needs one of them, 0.6 of this, 0.3 of that. We hand it to the teams and let them comment on the proposals coming in and let us know what they think should be going on, whether they think they should be involved. For the most part, we're still doing that in the 3 distinct teams. So we'll come to the digital innovation team and we'll bounce it around as all going, well, this looks a bit more data scientist. We can put a bit of RSE in there at the end. And also, we're still at the stage where the projects are coming in with funding. So often it's working within the hours they have and deciding what's going to be the most benefits. If they can't afford all of the full stack of people, which one's going to be most beneficial to them?
So I guess that ties into the next question here quite neatly, right? I think you said in that answer that you don't have project managers in that explicit way, or did I misunderstand?
I believe we have project managers for the big projects. What we don't have is a project manager for We don't have an official project manager for the group. I believe the title is project coordinator, and they're more ensuring that we have enough money to cover everything that we're doing, to pay all the staff at the end of the day, and letting us know when we don't have enough projects in and we need to go out to the organisations if we can find a few more or submit the grants ourselves. I think it'll be interesting to try and bring some more formal project management into just some of the everyday projects, which will help with that first question of deciding how much of each RTP we need.
Yeah, perfect. Next question, how is your group funded? Is it a mix of core funding and then project specific grants? How do you ensure that sustainability in funding?
So I guess by core funding, closest thing we have, again, I don't quite know what core funding means, sometimes it's an awkward word. We have national capability projects, and we have large grants that I believe come from NERC to cover national capability. These are things that we're required to do, you know, like some of the water monitoring and keeping some of this infrastructure alive. Part of those fall into our sort of, this is where the national capability bit comes in, program office there. That comes in as funding that then other projects can apply for to maintain and ensure the sustainability of their DRI. After that, it's specific project grants coming in to do individual things. There are some of the bits where I guess we're more proactive now as a digital research group, where we're going out and trying to find the funding for things that we think need to be kept leveling and have more sustainability to them.
Okay, fine. We're going to have time for maybe a couple more questions. So what frameworks do you use for the DRI itself? It's, you know, are you ITIL based? Do you use ISO standards for quality assurance and information security?
I mean, you know what those acronyms mean, so I think the answer is no. We are very much coming from our individual areas, our individual expertise, and bringing that together. The group itself has grown rapidly over the last 4 or 5 years to this group of sort of nearly 50 people now. And I think this is the next stage, one of the next stages we need to look at. Do we need to start using some of these frameworks along with project management on them as well? So
yeah,
it's asked me in a couple of conferences.
I guess it's interesting because you say, I mean, part of what you do is critical infrastructure for environmental monitoring for the government in some ways, right? So
yes.
The sort of quality assurance standards would you think maybe part of that?
And they probably are, but I've only been in the organisation a year, so I still haven't figured out everything we do.
I've been in it 5 years, so I'm sure I do it right.
Fine. And one more. I guess you mentioned that you talk about researchers, you know, this sort of cradle to grave things, right? What are the things that stop people getting involved right at the start of the project?
Not knowing about it, which is really odd, because when the research software engineering team was created a year and a bit ago, and it was created as a team, you know, they straight up hired 6 RSEs, no gradual to this. We toured all 4 sites. We gave a talk at all 4 sites telling researchers what we do. And I don't think actually it's not knowing about it. It's not realizing at the minute the benefit we can necessarily have to their research. You know, when you're applying for a grant, there's always the problem. The more money you ask for, that kind of has a relationship to whether it's likely to be funded or not. So if you can think of somewhere where you don't need something or you can't justify it, you're not going to put it into the grant. So I think it's getting across to the researchers how the digital research group can benefit their research, how it can benefit their grant. And part of that is just, it's going to take time to build up those success stories for them.
You're quite new as well. I mean, there's always institutional inertia about doing things in this like. Okay, so can we thank Robin and Matt again and all the rest of the speakers from this session.